It's been several years now since I designed this overhead dust shroud adapter for the riving knife on my table saw. And its main job is pretty simple: keep as much of the dust out of the air and my fingers away from the blade. It was one of the very first projects that I attempted when I got my first laser. And if you've been following me along for the last couple of years, you've probably seen it in a whole bunch of videos. Whenever I'm cutting something on the table saw, you will see this dust shroud. It's been so good that I pretty much never take it off. And basically over that time, the design hasn't changed at all. Now, I've wanted to revisit this project for a really long time, but the only thing that's been stopping me is that I don't have access to a specific tool that I've really needed or wanted to be able to take this to the next level. That is, of course, until now. So in today's video, I'm finally going to revisit and hopefully tackle some of the pain point problems that I had with the original design. I'm going to be using a combination of 3D printing and the help of today's sponsor, Monport. So let's get into it and cue the intro. Right, so what exactly am I looking to change here or update on the next version of the dust shroud here? There are 4 issues here that I'd like to try and solve, or at least tackle. 3 of them I think are going to be fairly easy or straightforward enough-ish to solve. One of them I think is going to be much more complicated. But let's start with the easy things first. And let's start with problem number 1, and that starts here at the table saw fence. So I'm generally about body positivity, but I'm afraid I'm going to have to fat shame my dust shroud here because it's just too wide. Problem number 1 occurs whenever I want to cut something that's a little bit thinner that I want to move the table saw fence up against or near the dust shroud. And because of how thick this design is, it means that I have not a lot of space, or I can't really cut something that's too narrow. So at the moment, if I want to safely cut something and still be able to run a push stick through the cut, I can't really cut anything wider than about 50 millimeters, which give or take is about 2 inches, which a lot of the time isn't really a problem, but I think I would like to try and skinny up or at least reduce the thickness of the dust shroud so that I can make slightly thinner cuts. Problem number 2 isn't so much as a problem, but something that I'd like to try and test. When I was making the original dust shroud, I actually experimented with the position of where the dust extraction was going to occur. And in one of my early prototypes, I actually discovered that having dust extraction right near the rear of the blade actually was quite effective. So what I'm wondering is whether or not I can maybe combine dust extraction that comes from the front and a little bit that comes from the back at the same time. There's obviously going to be challenges or maybe issues with splitting it, but you know, it's worth experimenting just to see if it makes any significant difference. So the third thing that I want to try and maybe look at fixing, or at least improving, we'll say, is how I put the dust shroud on and off. Now, obviously there's a bunch of scenarios in which I do need to take the shroud off. So anything that involves a really thin cut, or anything that involves where the dust shroud or the riving knife are going to get in the way. So for example, using my data stack, things like that. And over time, I've gotten quite used to doing it to the point where it's almost muscle memory. So putting it on and off isn't an overtly complicated process. It really only involves removing this one bolt and loosening this back one and then taking it off. So it's not an overtly complicated process to take it off. Putting it on can sometimes be a little bit trickier. I do need to use a little bit of muscle memory in terms of making sure that that bolt location goes through, because I cannot see it. And then I need to use 2 hands in order to tighten it. And then now the shroud's back on. Now that doesn't take very long. It's not an overtly complicated process, but I would like to be able to maybe attach the dust shroud with only 1 hand. So in other words, not having to use 2 hands in order to do the tightening. Maybe we can improve it so that I can just insert the bolt and turn it with 1 hand rather than having to try and do this with 2. Now the 4th problem I'm trying to solve is actually the biggest one, and that's when I need to do a very specific type of cut. Now the dust shroud works best when there's supporting material on both sides, so on the right hand side and on the left hand side. This helps create a vacuum, or at least an area where dust can't escape beyond the dust shroud itself. And that's fine for 90% of the cuts that I do where there's going to be material on both sides of the blade. However, there is one type of cut that I often do, and it still results in an enormous amount of sawdust being generated that just simply does not get trapped by the dust shroud. And that's when I want to do an edge cut. So in other words, if I want to clean up the edge of, let's say, a piece of plywood, which is very common, and I only want to run the blade along that edge just to tidy it up, then there's no material being supported on the other side of the blade. And as a result, the sawdust just spews out the side. There is no ability to capture that dust because effectively we're not creating a good enough seal for the dust collection to work effectively. Now, I originally tried to address this with a dust shroud cover or a side panel that would lower. So adjusting these two bolts here, or two knobs, would lower a guard that would then help to try and capture or to create a seal between the other side of the timber that's exposed. And while the guard does do a good job of channeling some of that sawdust away from the side of the table, because of this big gap at the front here, that sawdust cannot be captured into the channel here in the dust collection. It simply gets thrown straight out the front of the cut. So that's what we're going to have to try and address here. We're going to have to try and find a way to plug this hole up so that, or at least rechannel that dust so that it is being sucked up by the dust collection instead of being thrown forward. So the obvious place to start is with the original design, which is what we are currently looking at here in my 3D CAD program. I've cut away the view slightly here so that we can take a look at what's going on, but as you can see, it's not a complex design. We have layers of MDF sandwiched together to make our solid object. It's simple, but it is effective. Now you might think that to make it thinner, we're simply going to remove some of the layers, and yes, that is something we're going to do, but that introduces the next challenge that we have to solve. So the current design of the dust shroud hinges around the concept of using an existing shop vac fitting. And that's because obviously at the time I didn't have a means in which to make my own dust vacuum fittings. But with 3D printing, I now have that capability, which means that instead of designing the shroud around the adapter itself, we can mold or make or create our own adapter that is suited to the design or the size of the shroud that we want to create. So by moving MDF layers, we are going to be shrinking the size of the profile of the shroud, but it also means that we're no longer going to be able to use standard shop vac fittings. And that's fine, it just means that we're going to have to model and make and print our own adapters for this. The first change I'm making to the original design is adding a second dust port while also reducing the overall width of the shroud. My initial attempt was to simply add a second duct here, but it quickly became obvious that this aggressive angle was probably going to be asking a lot of the shop vac, effectively asking the dust to do a 180-degree turn. So in version 8, I refined that design by bringing the duct straight down instead, which makes the path of the dust a little less severe. And then of course I added a new dust port connector. While this looks complicated, it really isn't. It's essentially a rectangular box tube that profiles the openings and then slopes back to the adapter for our shop vac. I split this tunnel into two separate parts and printed them on my 3D printer. As a result of changing the vac adapter, I've been able to shave 2 layers off the shroud, which immediately reduces the size of it by 24mm or almost half the existing width. Now whether that ends up being too narrow or not, we'll find out soon enough because I think this is the first version we're going to build and test. Alright, it's time to start cutting, which means firing up the Monport Reno. In the previous video I talked about my initial experience moving from diode lasers over to CO2. And this is really where the difference starts to matter. The thing I've really been looking forward to the most is being able to finally cut clear acrylic, something my diode lasers simply couldn't do. Being able to work with clear acrylic is going to open up a whole new range of possibilities for tools, jigs, shop accessories, and for this project in particular, it's going to let me actually see what's happening inside the shroud. Another big advantage here is the working area. With the original dust shroud, I had to make quite a few compromises just to get the parts to fit in the working area of my old laser. The Reno 65 gives me a 600 by 400mm bed, which means I can finally tackle this without redesigning parts just to suit the machine. One interesting difference between my diode lasers and this CO2 machine is how focus is set. Instead of adjusting the focus at the laser head, you adjust the bed height itself. There is a small foot that magnetically retracts when the right focus length is set. So back to the cutting, we have 65 watts to play with here, and that makes short work of 6mm MDF and 3mm acrylic. And in no time I had a set of initial parts for our first test prototype. Assembly is going to be identical to the original design, just layers of MDF that are stacked on top of each other to form the body of the shroud, while some perspex goes on the very outside to give us at least a little bit of visibility of what's going on. We can then include our 3D printed dust port adapter, and of course our freshly cut perspex. My friend Dan from Riverside WOODWORKS put me onto a business that sells acrylic sheets for very reasonable prices. So if you're in the market for some acrylic, I'll link you to the Aussie business I buy from in the description below. I'm again going to be using these special fasteners called furniture bolts, sometimes also referred to as sex bolts or even bookbinding bolts. They have this male bolt with a female enclosed nut. Using these leaves a nice sleek profile and are ideal for this type of application. Assembly is straightforward, we just bolt everything together, we don't need any glue, nothing is permanent, which is going to be useful if we need to modify any parts in the future. It's going to be a lot simpler than having to remake the whole shroud again each time we want to make a small adjustment or adjust the prototype, so it'll save a lot of material as well. And with that, we have our first prototype ready for installation and testing. Alright, so we've got our prototype dust shroud assembled and installed on the riving knife, and we're basically ready to do some test cuts. So for this initial test, what I'm looking to observe or see is if there are any noticeable changes in the performance now that we've added that second duct. While the airflow is now technically being split between these two ports, we've also significantly reduced its width. So the effective area in which it's capturing is a lot less now. So overall, we can hypothetically think that at least it shouldn't make things worse. It might make things a little bit better, but whether or not those two things cancel each other out, I guess we'll find out. So the hope is just to see whether or not there's any tangible differentiation with this particular configuration. At very worst, we don't want to see any reduction, obviously, in performance. One thing I'm going to point out here is that I'm not going to get all scientific on this. So in terms of how we're testing, it's going to be basically observational. I think I've used the shrouds, or at least the base shroud, for a very long time, or long enough that I should be able to observe any noticeable changes. So I think that those will be quite obvious. We know that this performs really well, the original one. So we're just looking for those small, tiny improvements. So we're not going to be weighing any sawdust or anything like that. It's purely going to be observational, but I think that we can still gain a lot from that. So with that said, let's do some cuts and see where we're at. That's very interesting. So let's take a look at what I'm observing. So I've done maybe half a dozen test cuts, but for me, having used the original shroud so often, I'm pretty used to understanding the differentiation. So on paper, I really thought that this would be a significant improvement, but I really think we are hurting with this second port. As you can see, we are still getting quite a significant amount of dust shooting out this side. Now, for a lot of people, you might be thinking, that's not a lot of dust. For this particular shroud, or at least that shroud, I would think that there was something wrong. So I think the second port here is causing a problem. I don't think the form factor is impeding that. I think this is fine, having it a little bit shorter. But I definitely think that's actually making things not better. It's probably maybe about, a little bit worse. So as you can see, we actually got a lot of eject going out the back here, actually, which is unusual. I haven't seen that before. But I've got a lot coming out the side here, even though it's covered on both sides. So while it's not throwing anything in the air, which is the whole point of, a dust shroud, my original one would capture all of this, right? So I don't think we've made an improvement there. I think there's actually gone backwards a little bit. So I've just reviewed the footage from the first test cut, and there's something that I've noticed, and I'm sure you noticed it as well. What I'm seeing is that as I'm passing the timber underneath the shroud, as we get towards the end of it, it's being pulled down onto the timber. While we do want the dust shroud to sit close to the surface of the timber to improve dust collection, we definitely don't want it suctioning onto the timber itself. Luckily, I think the issue is something that I introduced, and I think it's very easy to fix. One thing that I can't do on the other dust shroud is sometimes I want to reference something from the blade. So for example, I might want to measure from the fence to the blade with a tape measure, or make a reference directly on the blade or something like that, where I can't do that with the dust shroud on. I have to take it off, do that measurement, then put the dust shroud back on. So one of the things that I envisioned that I thought would be a good feature would be the ability to actually allow the dust shroud to pivot. So if I take the adapters off, we can see that we're able to pivot the dust shroud out of the way, and I can actually reference and see the blade very clearly. So we can, measure or do whatever it is that we're wanting to do. And I think that that's a very useful feature. But on this particular prototype, I only pivoted it from this single point here. So while it definitely works in that manner, we are able to pivot it, we don't have a second fastening point to make sure that it doesn't go down further than it should. So I think the solution to this problem is very simple. I just need to use this mounting point that I've already got here and add an additional fastening point here. So something that can be very quickly loosened so that we can go up, and then obviously as we go down, fasten it so that the riving knife can't go down. So that should be a very simple fix, and I think I'll do that in the next prototype, so no problem there. So back to the proverbial CAD drawing board, the first thing I'm going to do is scrap the second dust port, as that was a bit of a bust. The second change I'm making is to remove the more complex 3D printed dust channel. It's added complexity that really isn't necessary, and I think I can achieve a simpler, cleaner shroud by simply extending the profile. I'll still need to print a new adapter, but it's going to be a much simpler one than the original. I have a pretty good feeling about this version, and while I'm glad I experimented and tested the dual ports, I think this type of version just makes more sense now. So back to the laser for some more cutting. And then assembly. So here we are again, prototype number 2 is assembled and attached to the riving knife. And as you can see, it's a bit of a deviation from the last version. So the first obvious change is that I've reverted back to a single dust extraction point. So I've ditched the second dust extraction here at the back and just reverted back to a single point, which is at the front of the shroud. The obvious second thing that I did was I've ditched the more complex 3D printed dust channel here in favor of simply raising the height of the dust shroud and extending the channel path here. And of course, that means I've had to print a new adapter at the back here. Now, as a bonus, this adapter actually solves the problem that I was talking about earlier before, where I was considering having to add a secondary mounting point here to lock the shroud altogether. What I've discovered through this sort of design is that while we're allowing the shroud to pivot, when we insert the new adapter, this is actually locking it all together, and now it can't actually move down. So those are the two major changes that we've done. The only thing really left now is to see whether or not this all still works as it's intended, and if it is an improvement over the previous prototype. So let's go do some more test cuts. Well, that does look a lot better. So let's have a look at what I'm seeing here. So once again, I've done half a dozen or so test cuts, and even just with those, we can see a marked difference. So I'll try and put a side-by-side comparison to see, or to show the differentiation, that even after a few cuts, I could definitely tell the difference between this version and the previous one. So, and as you can see, there's basically very little. There's a tiny little flake there that's got away. But other than that, the Shroud is doing a really good job of capturing almost all of that. So I would call that a success. Very happy with that. We can sort of lock in this form factor and move on to the next part. So happy with that. Let's now talk about next steps. Okay, so the final thing on my list is what I'd consider to be my biggest pain point, and that's cleaning up the edge of timber, specifically if I'm working with plywood or form ply. And I originally tried to mitigate this by adding a side panel that could be lowered to help channel the dust. And while that does help to a degree, there's still a significant amount of dust being thrown forward that I'd really like to try and ensure is captured. Ever since that original dust shroud video came out and I talked about not really solving this problem, a lot of people have reached out in the comments, email, etc., all suggesting the very same thing. And that's to go out and get myself some nylon brush trim like this. And yes, I know that this material is very commonly used for that type of application where we want to try and capture or retain where dust is going. But there are a couple of reasons why I don't really want to use this on this particular shroud design, and I'll talk about those now. So reason number one why I don't really want to go down the dust brush path is because of visibility. If I start incorporating a brush design of some description around my shroud, I'm going to start limiting my visibility, and it's the one thing that I really enjoy with having a clear dust shroud, is being able to see what's going on, how a cut is progressing. And by having some sort of shoe like this, I'm really limiting my visibility. Secondly, the profile of my dust shroud is quite thin, and having a brush that's quite close to the blades may actually introduce a safety issue. Most of the time when I see this kind of stuff implemented on dust shroud or hoods and things like that, they're really big dust shrouds. So they have plenty of clearance for the blade, plenty of area for this to work in, and I just don't see how with our small footprint dust shroud here that we can really make this work effectively. But I think my biggest problem with using a brush like this is that it's not designed to actually channel dust to the extractor. It's just there to capture or stop it being thrown and ejected all over the place. So while I think it would work in terms of limiting where the dust can go, it's actually not going to extract any. So I feel like I'm going to be cleaning it every single time I do a cut because there's going to be sawdust captured in it, which is against what I'm trying to achieve here. I want that dust to actually be captured in the extractor. So the solution I've landed on is something that I'm dubbing the Snorkel. Wow! It starts with a new intake channel at the front of the shroud, located right here. You might have noticed this feature in the previous prototype. I'd already built it in temporarily and plugged it because I had ideas for it, but I wanted to properly test the base shroud first before getting ahead of myself. From there I modeled this scoop which runs the full length of the shroud and connects directly into the front intake. The idea is to capture the dust that's thrown forward past the blade and redirect it back into the dust collection system instead of letting it escape out the front. In theory, this should help deal with the dust that the main shroud simply can't catch during edge cuts. So after a quick trip to the 3D printer, we now have what I'm dubbing the Snorkel. And to fit it to our dust shroud, it's pretty straightforward. So we'll use our feature that we've implemented that allows us to pivot the shroud. There is a cap here, or a plug that I remove, and we can now insert our Snorkel. So it should be just a case of sliding that in like so, and then popping it in. Now, to say that I'm happy with that would be an understatement. That has actually performed even better than I could possibly have imagined. It's captured pretty much all of the dust. There's basically nothing major to write home about in terms of what has been ejected. And I would say that that's a pretty successful test. Now we could easily stop here and say, well, this is the final version. We don't need to make any further changes. Everything works exactly the way we want it. And basically I can call it a day. But of course, I'm not going to do that. I am going to make one more version with the help of the Monport. So with the power of video editing. And there we have it. We have our new dust shroud completely cut out of Perspex on the Monport, the Reno 65. It did a really good job, really nice clean cut. Didn't take very long to cut at all. And there's a couple of little tiny things that I've changed here. So the main thing that you'll notice that is that there's an extra knob here. I've just made this a bit easier to adjust. So now we can tighten it and it'll stay up. So we can now lower it, tighten it, and keep it out of the way when we're doing our measurements. It also means that I can take this off completely, so I can remove this and we can actually take the top of it, so it'll actually make it a little bit easier to remove. But other than that, I'm really pleased with how it's come out. I mean, it looks pretty cool. And functionality wise, I think this is going to be really good. Now, I did print a couple of extra snorkels. So here's the snorkel from before. I printed a slightly larger one for larger cuts. If I look at all of the criteria that I had for the dust shroud, I wanted it to be a lot skinnier, so tick, we've done that. I wanted it to be easier to put on, so tick, we've done that. So with the acrylic here, we can absolutely see what we're doing now. I wanted to try the secondary port dust thingy. Didn't really work out, or let's be honest, wasn't really necessary. So we've ditched that. We'll call that worth testing, worth exploring, but in the end, not necessary. And then obviously we wanted to solve our edge cutting, which I think we have a pretty good solution for that with the snorkel here. I think there's room for some enhancement improvement, but for now, I think we'll leave it at that. So that about wraps things up for this one. A big thank you to Monport for their ongoing support in providing the laser. Go check out their products if you're in the market for a quality CO2 laser. And if you're interested in plans for this particular dust shroud, let me know in the comments. I'm still a little bit on the fence on whether people will actually want these, so if you're interested, please be sure to let me know. And of course, we can't leave without a big thank you to our newest channel members, as well as all the existing ones. Your ongoing support means everything. Thanks for watching, and I'll see you on the next one.